A very good morning to you all. Today we will begin with the new chapter, three-phase AC circuits. After having understood the single-phase AC circuits, series, parallel and combination, now we are moving to another variant in circuits as three-phase. How is that three-phase? We all very clearly know generation of electricity takes place in bulk. Therefore, that is not comfortable with a single phase AC to generate and deliver the power. In fact, it is polyphase system. More than one phase kind of system is practiced, and among them three phase is most popular. When we have a single phase, one line, one return is the nature of the single phase. When we have a polyphase, number of conducting line, number of return line, we call it as a poly multiple. When I have a three phase, there are three conducting line, one return, or a three conducting and one of them or two of them act as a return. That we characterize as a three phase circuit. All the properties, facilities or the applications of polyphase systems are experienced using three phase AC system. Hence, three phase AC systems are popular. Whatever the polyphase system can do, that can be ensured, attained by three phase system itself. Hence, three phase system is moderate, comfortable, not complex than polyphase system. Hence, it is practice. In the present scenario, electricity generation takes place in three phase mode, pumping into the grid, transmitting it, retransmitting it, distribution and sub-distribution to the individual household takes place either in three phase or in single phase. Therefore, three phase is next popular mode of circuits in electrical notations. So, we are studying the three phase AC circuits, the concept of generation, advantages, configuration, measurement of power and some numerical problems associated with that. It is a very interesting chapter, very short duration chapter. We can complete it in a very best time which is allocated to this. Yes. Introduction to polyphase AC circuits. Under this polyphase AC circuit, we are confining ourselves to three-phase AC circuit only. When I have n phases, n phase may be 10 phase, 20 phase, like any number n divided by means 360 divided by number of phases. When I take a fraction, that give the vectorial difference between the voltages. Suppose I have a three phase AC system, 360 divided by 3 if I do, that gives you 120 degree shift in phase. So, each phase like Vm sin omega t, one phase, Vm sin omega t minus 120, second phase, Vm sin omega t minus 240 is a third phase. Like that, between the phases I will have difference in their representation and synchronizing. That polyphase system will have 360 divided by n. N stands as number of phases. For us today, we are beginning three phase AC system. Then phase difference between each one of the phase is 360 divided by 3. That stands as 120 degree per phase. That's what we need to concentrate ourselves. Now we will try to understand what are all the meritorious features that the three-phase AC system is possessing in comparison to other. The other stand here as a single phase first and polyphase in later. Let us see, this is one of the important question you may get. So, three-phase apparatus is more efficient than single-phase apparatus. Now, you can see this equipment, you may recall a transformer. A transformer is an electric machine or a static electric machine which transfers electric power from one circuit to another. Okay. While doing so, it can change the power, it can change the voltage, it can change the total voltage or current what it delivers, but keeping the power constant. So, it is a transfer of power from one electric circuit to another circuit. And when it is the equipment of single phase notation and three phase notation, definitely three phase notation equipments are efficient. Their performance is superior in comparison to that of single phase. If I think of a motor in an industry application, yes, motor of the same capacity, HP 10 HP and 10 HP when I compare. Performance of the equipment, if I view equipment performance wise, three-phase equipments are superior in their role. In that regard, three-phase apparatus, whatever a furnace you take, heater you take, motor you take, or any appliance with respect to electrical, which is a three-phase construction and single-phase AC construction, I can classify from the performance perspective of that as three-phase equipments find best in their approach. Then for the same capacity, see the second feature, three-phase apparatus costs less than single-phase apparatus. This is very interesting aspect. In line with this, let us imagine a 10 HP motor I am in need. What is a motor basically? An electric machine which converts electrical power to useful mechanical power. Will you choose a single phase motor of 10 HP or three phase motor of 10 HP? Question comes to our mind. In that regard, the equipment by certain capacity, when I compare with the three phase mode and single phase mode, three phase mode equipments are cheaper compared to single phase. Why it is so? The constructional viewpoint, because single phase machine will have only one winding. It is a single phase, one line, one neutral. All the winding conductor has to be connected to single phase interconnection. So its ability, which has to justify a certain capacity, become bulkier in nature. It become bigger in construction. Involvement of huge number of conductor make it costlier. The same capacity when I design for three phase, the size also become less. Investment of material in developing that equipment become lesser and it costs you lesser. This is how you will find industrial application work with the three phase only. You may ask me, why not our households are not working with the three phase? Yes, three phase equipments are not used in household because the capacity of usage, I may use a mixer grinder. What is the capacity of that in a house? Hardly 500 watt to 750 watt. I may use an electric geyser, hardly 1 kilowatt to 2 kilowatt. I am not using in tens of kilowatt, correct? In that perspective, we are not taking a delivery to our house as a three phase. If I want to take a three phase, it may be a multi-storied building. Input to the building is three phase. They branch it into individual circuits later. For them, bulk power usage whenever is there, three phase is advisable. In that perspective, whenever you are choosing a three phase or a single phase, your judicious choice should go. Suppose you decided to go for three phase, then equipments based on three phase must be utilized. Then they are superior compared to single phase. In that way, three phase equipments are cheaper than that of single phase equipment for a certain capacity, HP or kilowatt is considered. This is another important aspect. The size of the three phase apparatus is smaller than that of size of single phase for the same capacity, hence require less material and less space. This is very important. Now this is very interesting aspect. Now look for a farmer. A farmer in the house pumping a water pumping application. Say he requires a 10 HP motor to be connected to a pump to pump the water from the underground to the farm. Then 10 HP he may choose a three phase or single phase. Definitely we know when the 10 HP motor on a single phase capacity, if I purchase is costlier and it's bulkier, larger in dimension, which definitely when the size of the machine increase, investment in developing that material also increases, casting of the motor or inside winding, insulation, stamping, shaft, all interconnected mechanism involved cost you more. And it become naturally bulkier and occupying a lot of space, then it is a challenge. Therefore, size of the equipment is considered. How do you fit it? Compact. At that time, the size when you compare and performance of that you compare and construction wise material usage is considered, three phase equipments are superior. But some of the location where single phase is to be used because of the supply. I cannot use three phase over there. That is a contradictory situation. When it is a comparison by size, shape, investment, so three phase equipment find superiority over the single phase. The another one, for transmitting the same amount of power over the same distance under the same power loss, the amount of conductor material required is less in case of three phase AC system than that of single phase. I will tell you the scenario. What is the meaning of this? I can tell you the gist of this fourth is there is a saving of 1/4 of weight of copper or aluminum if I use three phase mode of transmission. That's all. What is that? Imagine for a point number 1 in the real power system to a point number 2, a distance of certain kilometer. I want to transfer the power. How do you transfer the power? You may transfer the power from DC application. You may transfer the power by single phase application. You may transfer the power from three phase mode of application. Which one is more economical? That is the meaning of this. If P megawatt, P is a megawatt, say 100 kilowatt or 1 megawatt, like that, certain amount of power. I am pumping from point number 1 to a point number 2, which is so much of kilometers of length. Then to do this activity, which is your pattern mode of pumping, single phase mode or three phase or any other DC mode. In that comparison, if I utilize three phase kind of delivery, either in star mode or a delta mode, we have a mode. So it is a three phase mode. When I transmit the power in three phase mode, the copper or aluminum conductor used to carry the power has to be pumped, current has to flow all along the conductor and receive at the other end. So conductors are very necessary. Running from point number 1 to the point number 2. So physically conducting material either in copper or aluminum or alloys are used. Their tonnage, weight them on a weighing balance or weighbridge. Conducting material weight for the point number 1 till the point number 2, total kilometers that you have fixed. Weight of the copper or aluminum is saved by 1/4 of the material when I choose the mode of transmission as three phase. Hence three phase AC is popular. I can do it with single phase also. Conductor become thick enough, diameter of the conductor become larger to carry large current, higher amount of current. That's why in comparison, three phase mode of delivery of power is superior, which save 1/4 of weight of conducting material when I choose three phase mode of delivery. Next, fifth point. Three phase motors produce uniform torque, whereas the torque produced by single phase motor is pulsating. This is from the perspective of application. Let us say you are taking a motor choice for a conveyor or a fan. So which kind of fan you use for application in industry, whether three phase or single phase? Choice is yours. Suppose if you take a three phase motor, they are self-static, first thing, and they produce uniform torque. They are not going to make any pulsation, stop, start, stop, start, stop and move, rapid and slow. That kind of intermittent or pulsational torque jerks are not seen in three phase motor. They are constant speed, uniform in their work. The same phenomena when I compare with a single phase motor is not there. They are not superior, they are inferior compared to three phase motor. Pulsational torque or that kind of comparative inferiority is noticed in single phase motor. Hence, when you are applying to a particular special application, uniformly or uniform torque is required, three phase motors are your best choice. Therefore, application perspective for a loading, conveyor, belt, pump, anything of such, three phase motors are used. Then the next one is the connection of single phase generator in a parallel to give rise to harmonics, whereas three phase AC generator can can be conveniently connected in parallel without giving rise to any harmonics. What do you mean by this? Now, for this sixth point, let us say, how do generation of electricity takes place? Is there any only one generator generate entire kilowatt or megawatt required by the country, or there are so many number of generator generating small megawatt by amount connected in parallel, sum up and give to the power? What is that reality? Yes, there is no single big or large generator. First thing we should note, there are several generator of different capacities as defined and designed. They are made to run by different resources, hydro, thermal, nuclear, or any other resources available. That megawatt or kilowatt what it is producing, put in parallel with the neighbor and other, we call them as a parallel. They are supposed to inject the power into the transmission grid. When I connect them in parallel, definitely it will have an influence. Three phase you are doing or single phase you are doing? There is a question. If it is a three phase by mode, three phase generators run in parallel, very sophisticated. They will not cause any adverse switchings or harmonics into the system, which are unwanted inductions. Harmonics are nothing but diversions or deviation in the frequency, distortions in the waveform nature, cause loss. That kind of harmonic injection, introduction into the system is very negligible in three-phase system when generators are put in parallel. The same is not true when a single phase AC generator of 100 or 200 generator together can meet your requirement. When they are put in parallel, there is a quite natural observation of harmonics which cause a deterioration of the quality of the power or nature of the waveform, etc., which we cannot do immediately. We have to adopt some additional measures to that. That is not there in three phase. Three phase systems are popular and they do not cause such inductions of harmonics. They are very comfortable. So therefore, three phase AC generators operation in a parallel is very interesting and it is free from such harmonics, hence it is preferred. That's the only outcome. In case of three phase system, I said there are two types of systems, star connection and delta connection. However, is that it is possible to have two types of voltages measured in three phase. So one is between line to line, we call as line voltage. Between line and common point, we call as phase voltage. So this is not there in single phase. Single phase will be having one line, one neutral. Only one voltage. We measure from line to neutral or neutral to line. You will get 240 volts. That's all in case of Indian continent. In case of three phase AC system, in the current perspective, 443 phase, if I say, between any two line you are able to read 440. Between any one line and common point, we call it neutral, 240 you can see. Two different voltages you can measure. The advantage of this is, if the system is three phase, single phase is inherited from that. It is there readily. No need to generate single phase. Single phase is what? One line, one common point. Tap and get it as a single phase. You want three phase? All three lines you take it. Like that, three phase AC system is having a facility or a provision to have line to line voltage and line to phase voltage. This is the advantage of three phase AC. So from the existing three phase AC, delivering power to the single phase loads is just draw a line and connect. This is not there in other single phase AC. Then the next point, three phase motors are self-starting, whereas single phase motors are not self-starting. Hence three phase AC system is popular. You might have seen our individual domestic house, water pumping motors are fixed with capacitor to start the motor. So you will be having single phase motor to pump the water from underground sump to overhead tank. That time you will be using small quarter HP, half HP or 1 HP kind of motor to pump the water from underground tank to overhead tank, like that. So there, if it is a single phase motor, probably you will find a small tubular cylindrical like one capacitor fixed on the top of that. That capacitor is used to start the single phase motor. That is a starter. The same kind of starter is not required for three phase motor, because three phase motors are self starting because of rotating magnetic field. We will study this when you go to last chapter of the syllabus. Rotating magnetic field is resulted when three phase motors are started from the supply. Automatically they will start rotating. That is the advantage of three phase AC motor. Hence I can say three phase system is popular because three phase motors are self starting compared to single phase motor. These are the few advantages what one would get from the three phase AC system in comparison to single phase AC system. Hence three phase AC system is popular. If it is so popular, then how it is generated, how it is represented become a question. Let us see here. So how to generate polyphase AC or three phase AC? The principle of generation of that is very simple: electromagnetic induction. It means if I go to a next slide, you will be able to see generation of three phase AC. You will find a machine here. The machine's front view I have shown. The stator body, stationary part of the machine, is having circular or cylindrical object which is mounted with the foot or base, having windings in the form of conductor, red and red, green and green, blue and blue. You can see they are the three phase windings. Three phase windings. So because it is a three phase AC system I am speaking. When it is three phase AC system, there are three windings. So each winding is wound all around the machine, and brought out for the end connection. You can see here in the right side I have three windings: winding A, winding B, winding C. These windings are inductive coils and they are in the stationary part of the machine. Okay. Then centrally what you find which is a rotating, it is called field system. North south, electromagnets. Electromagnets are made to revolve. Then what is a generator basically? Generator is an electric machine which converts mechanical energy into electrical energy. Therefore, it should be connected to suitable prime mover, mechanical drive it should be driven by. Therefore, shaft of this machine is to be coupled to a turbine or a diesel engine, anything which can rotate it at a constant RPM, so that the magnetic flux associated with these poles, NS poles, like one pair I have shown, there may be one pair, two pair, 8 pair, 16 pair, like that. Number of north-south poles are mounted on the rotating member. This is one of the chapter, 9th chapter, three phase AC generator, construction and study. We will do that once again there. Meantime, three phase AC generation takes place by rotating field mechanism. So just go back to the previous chapter. Generation of single phase AC we studied. Rotating conductor mechanism, square frame of conductor or rectangular frame of conductor was made to rotate, cut the lines of flux. That was what we have seen. Here, to generate a huge amount of power, bulk amount of power, that will not be an efficient mode. So opposite to which is group of conductor by large number of conductor in the form of winding are put in the stator. Number of poles of suitable pole strength were driven by the prime mover. Change of flux linked with the conductor when the when the rotor is revolving happens. Then that induction of EMF in the conductor and taking out of that happens. It's a dynamic kind of induction. As I was speaking, there are three windings, group 1, group 2, group 3, electrically displaced 120 degree among each other. That was I am speaking. 360 divided by number of phases. 350 divided by 3 works out as 120. Therefore, there exists 120 degree phase difference between induced voltages of group 1, group 2, group 3, like that. So therefore, if I speak, if the windings are such a way connected, so how they are connected? There are two types shown: star connection, delta connection, like that. We will see that whatever the value here, the same thing I have shown here. I'll go back one moment. Okay, so I'll go to the previous. So principle is a single phase supply is generated using a single turn conductor, but it is not so. So we have armature winding put into three groups which are displaced 120 degree among each other. They are made to rotate. So these coils are mounted here. You can see here these coils are 1, 2, 3 which are here in the stator body. Leads are brought out. Leads are brought out. So then the connection of these windings may be either star fashion, we call it as a star looking like this, or maybe like a triangle like this, delta fashion. We will see that later. Okay, it is connected and so-called induced EMF in the conductor due to the change in flux linked with the magnetic field and conductor. There will be induction of EMF. That induced EMF is taken outward. Yes, that is taken in the terminals, that is given by VR. If I take a reference R group, VY second group 120 degree lagging, VB again 120 degree lagging by second group. All together I can have induced EMF in the first group is Vm sin omega t, induced EMF in the second group is called as Vm sin omega t minus 120, and induced EMF in the third group be Vm sin omega t minus 240, or it can be plus 120. Minus 120 means behind the VR, plus 120 means above the VR, both are same. So therefore, when I have three symmetric waves, assuming that machine is wound symmetrically, we will have three waves Vm sin omega t minus 120 minus 120 another. This is 240 total. So therefore, these three waves if I plot, I will be getting a waveform. You can see the white colored one group A and a blue colored one late by 120 degree. Can you see this? Late by 120 degree and late by 240 another one. So these are three phase wave, one sinusoid. Why to trace it like this way? White one, correct? This way, one cycle. And this 0 to 180, the first mark is 60, 120. So late by 120, you start second wave like this. You complete this. And late by 240, you can see last one here, yellow beginning here, like this. So this is how drawn. You can see these markers running on this, red group, green and blue. So they are internationally recognized as RYB in Asian continent and UVW RST in European continent. So whatever is that, there occur a perfect phase difference in three-phase system by 120 degree. So we should have a common exchange of identification, because a machine which is having a RYB phase sequence, RBY phase sequence, that matter you. That's called as phase sequence. Phase sequence is the one, the sequence in that order peak of the wave occur. You can see here, if I show you the next diagram here, suppose you have phase 1, V1, you can see this black colored marking I have done, phase 1, can you see this, correct? Phase 2, V2, late by 120 degree, I have marked here, can you see this, correct? And the phase 3, V3 is starting late by 240, you can see 120 plus 120, it begins here. So what is the phase sequence meaning here? Phase sequence meaning is, it is the sequence of waves attaining their peak in the order. Suppose group number 1 is say R. R group attains its peak first, correct? Then second is Y. Y gets its peak second, and the third wave gets its peak third. The peak head you can see, R group first, Y group second, B group third. So phase sequence is called RYB. So what is the meaning of that? It is the order in which peak of a respective wave appear. Then vectorially when I draw the waveforms, you can see here the similar one with the color is shown, red color, yellow color, blue color for the distinction. You may ask me, are they really in colors? No, they are recognized for our understanding. So when I say RYB is the phase sequence, one of the group which is a reference, which is beginning from 0 mark, turning it to 180 degree and 360 degree as one cycle. Then second group Y start late by 120 degree. You can see here, its beginning on the 0 scale is 120 degree later. It makes its one cycle completion. Then similarly 240 degree later from the 0 mark, it is a B start, means third group. This way RYB, you can see hump 1, 2, 3. In what way they are appearing? R first, Y second, B third. That is called phase sequence. Phase sequence is the sequence of attainment of peak of respective waves. Suppose if I say RYB, then how it is represented by vector? We know that vectorial representation of waves is possible. A vector corresponding to red group is drawn as a reference. Can you see here? Horizontal vector representing first group, which represents 0 mark, 0 mark. As it proceeds, it rotates in the anti-clockwise fashion. You recall back single phase vector, phase difference we have learned? Yes, this represents first wave. What about the second wave? Second wave is lagging behind it by 120. Then I will mark 120 degree behind. Another arrow, yellow in dimension and color, which is yellow phase. Then third is 240. From this mark, I mark 240 or this way 120. Then I will tell this rotating vector be revolving in anti-clockwise fashion. Then what is the phase sequence I said? It is a sequence in that order peak of a wave appear. First peak when I move from time plane, here if I start my journey, I will see first peak is red, second peak is Y, third peak is B. So to get this by vector, if I stand here and as an observer, vector R goes forward, vector Y comes to me and vector B comes to me, which I have seen as red gone B, yellow has come to me and blue has passed away from me. In that way, I will find rotating vector rotating such that R, Y, B are appearing to me, coming towards me in that order. That is called phase sequence. Suppose if I reverse the direction, can you see this? This anti-clockwise fashion, if I make clockwise, what will happen? First is R, next comes immediately blue, next comes yellow. That means this yellow line which I have shown, it should be instead Y, it is blue. Then sequence can stand as R, B, Y. So we can say if RYB is the anti-clockwise direction, RBY is a clockwise direction. So this has a lot of significance in motor. If power supply input to a motor given and it start rotating in a particular clockwise direction, to change its direction, what we have to do? Supply input we have to exchange any two lines. Automatically it is going to rotate in a opposite manner. For that, phase sequence is very important. Phase sequence is the sequence in that order the peak of a respective wave appear. For a certain RYB phase sequence, if the motor is rotating in a clockwise direction, to reverse that we have to replace or exchange any two connection, that will make it clockwise. So there it is important. For me to get into this concept, interesting is how is that three phase waveforms are drawn. This is how three phase waves are drawn with the R group as a reference, second group Y as a follower by late by 120 degree and B in the third by 240 degree later, and it makes a sinusoid. This is how it is being written. So that is what is being noticed here. So this rotating field mechanism make an induction of EMF. Those induced waves are plotted in this manner. If it is symmetric machine, we will be having Vm sin omega t, Vm sin omega t minus 120, Vm sin omega t minus 240, symmetric in dimension. Dimensions are symmetric and there is a phase difference between beginning of first, second, third systematically by 120 degree. That is what we have to see. Generation of three phase AC takes place by rotating field mechanism, group of magnetic poles and group of conductor incorporated here. Field is rotating and conductors are stationary. There occur induction of EMF collectively in the winding, which is already wound in the three phase notation, either in the star fashion or in the delta fashion. So-called induced EMFs are symmetric in dimension if the windings are perfectly balanced. Then we will get magnitude wise similar, but phase wise I will get a difference of 120 degree because it is of three phase notation. This is about the generation perspective of that. So this additional thing what you find on this page is additional only just to show how three-phase AC generation takes place, how you are able to get these waves, then how do you get two kinds of connections possible. One is star connection of these windings. These three windings are suitably interconnected one to one, one to one. That connectivity makes it either star interconnected or delta interconnected. So that we will see in the second aspect. But now for me, three windings are assembled in the stationary part of the machine. Induced EMFs are taken out and they are represented as a waveform. This is the knowledge which is required for generation of three-phase AC voltage and representation of waves and understanding of symmetric or balanced system. So symmetric, when I say a word, it is to have the perfect difference of 120 degree among each other, having respective magnitudes and balanced system. So this is how we need to see. And the phase sequence, when I speak about the sequence, in that order the peak of the wave appear, R, Y, B, R first, Y second, B third, or any other pattern I have to speak. Later I have a sequence, RYB makes a clockwise, any other random combination makes a anti-clockwise to clockwise direction, like that. So we need to be careful about this. Then once I have a system, waveforms are represented like this. So vectorial representation is to be understood. Then each vector representing each phase should have 120 degree difference among them. Then depending upon the phase sequence, vector need to be given a direction. Now in this mark, a vector is given anti-clockwise fashion because to show you RYB phase sequence, this vector has to revolve in anti-clockwise fashion. So therefore, this is how we will get a representation. Once we come to the understanding of that, we need to know some more important aspects, some important terms related to three-phase AC system. Here we got to know three-phase AC system may be either star connected or delta connected. Star connection is the one in which the 6 points, each winding is having 6 points, start, end, start, end, start, end, like that. We have 6 terminals. Each group is having 2 terminals. Totally I have 6 terminals. These 6 terminals are interconnected like this. You can see this. How many terminals you get outside? Here I have 6 leads, 2 here, 2 here, 2 here. 6 points are there for external contact. But that is optimized as what? 1, 2, 3 and a common point at the center. So totally I have 4 points. In case of delta connection, out of the 6 points, there are 6 points externally. They are internally connected in this way. How many are available as external world? Only 3 for the external world. So I have three-phase AC system can be either star connection, it will have 4 contacts outside. It can be either delta connection, only 3 contacts are there for an external world. So when I have a connection possible by this way, we say three-phase star connection, 4-wire system. Three-phase delta connection, 3-wire system. When I have a 4-wire or 3-wire system, again it becomes necessary to understand the distinction of phase voltage, line voltage, phase current, line current, like that. For that to understand, basically we require how is that three-phase system is interconnected. It is interconnected either as a star or as a delta. First thing we should notice. Then I will find leads here. Can you see here? This will be studying another derivation itself. Meantime, 3 leads are there. If I measure voltage between lead 1, lead 2 or lead 2, lead 3, we can call it as a line 1, line 2, terminal 1, terminal 2 or 2 to 3 or 3 to 1. Totally, I am measuring voltage between any of the 2 lines. We call it as line to line voltage, line to line voltage, or any one voltage between line and common point here. This is a common point here. This you hold as a measure and you touch here, you get a phase voltage of A group. If you touch here with respect to this, you will get B phase voltage. If you touch common point and this instrument with this point with the instrument, that will read voltage of phase 3. I mean, I am able to distinguish two different types of voltages. Voltage measured between any two line as a line to line voltage, any voltage between one of the line and a common point, we call it as phase voltage. So this is possible in three-phase star system. Similarly, three-phase delta system. So whatever is the induced voltage in A group, B group, C group due to the generation of three-phase AC, the line voltage, what I see from three lines here, 1, 2, 3, there is no common point absent here, no common point here. So only three lines are there. So voltage between 1 and 2 is the A group, voltage between second and third is the B group, voltage between third and first is C group. I would say there is no difference between line voltage and phase voltage. Both of them are one and the same. That is possible in delta connection. So I introduce you line voltage, phase voltage, which is different in star connection. Line voltage and phase voltage is one and the same in delta connection. This is voltage perspective. Then with respect to current, whatever is the current entering the line or leaving the line is called line current. From the terminal perspective, from this machine going out or coming in, which is called line current. Whatever is the current coming out of the voltage induced in the group, phase current coming out or going into the phase, that is same. Whatever is coming out, come out here. Whatever is entering here, enter here. I mean to say line current and phase currents are one and the same in star connection or Y connection. But here, whatever is the current entering or leaving the line is no more same. It come and branch here. I would say phase current is the current flowing in the phase winding, line current is the current going out or coming into the line. So line current and phase currents are different. So it becomes necessary for me to understand that. That is what is put here, terms related to that. Then I have similar rough sketches over here. You can see the star connection or Y-like connection is shown. Line 1, line 2, line 3, 120° among each other is mentioned. Okay, this is a common point. So now the first definition what we want to do, phase current. It is defined as the current flowing through each phase winding, either generator or a load. It is denoted by IPH. It means to say, I was speaking. So suppose if I speak of this current entering here and entering this is a phase winding. So current leaving the phase or entering the phase, that is called phase current. Current flowing through the phase winding, either a generator means leaving out, motor means absorbing. So current flowing in each phase winding in this, we classify it as phase current. So therefore, the another current what I can tell is line current. Line current is defined as the current flowing through each line conductor. You can see here, line 1, line 2, line 3. Whatever is the current entering here or leaving here is called as line current. So it is called as IL. The current phase is called as IPH, phase current. By looking engineering perspective, whatever is entering here, the same current enters here also, or whatever is leaving here, the same current exit here. I would otherwise say, in case of star connection, line current is same as phase current. If I take the second line, whatever is entering here, that is entering here. Whatever is entering here, that is entering here. Whatever is exit here, exit from this point. Whatever is exit here, exit from this point. So it is same. Line current and phase currents are one and the same in three-phase star connection. What we learned now is the current flowing in each windings of a generator is called as phase. The current entering or leaving the machine terminals, going out to the external world or getting into the motor windings, that we call as line current. Line current and phase current we can distinguish. Generally, R, Y, B are the internationally recognized convention in India and Asian. So, R, Y, B I call as IR, IY, IB as a line current, IPH as a phase current. This is what we can say. Then, in case of delta connection, the same concept. If I see this diagram, whatever is the current entering the line, leaving the line is called a line current as per the second definition. It may be IR, IY, IB. Now look into the phase current. Is it the same? Definitely no. If IR enter here, it find a path here. I don't know how it is flowing in partial. Therefore, phase current and line currents are not same. Phase current and line currents are not same. Phase current is what? Current flowing in each windings of the phase. Phase R, phase Y, phase B, put in the form of a delta. We will see it later. What is delta connection? For me now to make you comfortable, current flowing in each group, phase group is phase current. Current flowing through the terminal or a line is called line current. In comparison, line current and phase currents are one and the same in star. Line current and phase currents are not same in delta. This is what you can get. Correct. Next parameter what to understand is phase sequence. I was speaking to you earlier itself. It is the order in which 3 coil EMF or current attain their peak respectively. RYB phase sequence I was speaking. Then R group should go to peak first, then followed by a Y, followed by a B. That is a sequence. In that order only respective peaks are seen when I plot the representation. Then the next question I had, balanced system. When the word balanced says the set of induced EMFs, ER in the first group, EY second group, EB in the third group, they should be same in magnitude. Okay, they should have perfect phase angle difference, 120, 120, 120 like that. That is called balanced system. System is having equal in dimension, Vm sin omega t, Vm sin omega t minus 120, Vm sin omega t minus 240. What it says? Peak must be Vm, 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 same, and omega t, omega t, omega t, progressing also same. Only difference is phase angle in them, 120, 120 like that. If it is perfectly viewed in a balanced way, that we call as a balanced system. When such balance is not seen, you can say unbalanced. Unbalanced system is the one in which voltages are imbalanced. Peaks of R group, Y group, B group need not be same. Phase difference among them need not be 120. That system we call as unbalanced system. So, our study refers to balanced system because of simplicity. The another is load. When it is a generator, I can think of this. If it is a load absorbing the power, the same thing I can say. Balanced load means what? Load is absorbing equal power in phase R, phase Y, phase B. Load is is drawing the power in all the arms of it balanced. Unbalanced, rapid loading. R group is heavy loaded, Y is light loaded, and B is most probably not loaded. It's called imbalanced pattern of load. Is called as unbalanced. So it do happen in the real world. We cannot balance the system perfectly to its closeness. It is approximately balanced. But in such a system has to cooperate and work. For that, classification is balanced generation system, unbalanced. Balanced load, unbalanced load. We need to understand. The another term which is missing here, voltage. Line voltage and phase voltage, which is what I have already defined. Voltage between any of the two lines, if I measure, that we call as line to line voltage. Here or here also, line to line voltage. Whatever is the voltage measured between any one line with a common point here, star is having a common point, delta won't have a common point. When we construct the study of delta interconnection, we will come to know there won't be generation of common point. When it is a common point, voltage between any one of the line, any one you touch and touch with a common point with the instrument, you will be reading phase voltage. So phase voltage is the measure of voltage between any one line with respect to common point. Line to line voltage is the line voltage between any two lines of the system. So there is another word missing here, line to line voltage, line to phase or line to neutral, which is called as a phase voltage. So when I speak of that, in case of star connection, line to line voltage and line to common point voltage are not the same. So they are different. Line to line voltage and phase voltages are not same in star connection. But in delta connection, you will find between R and Y, it is called a line to line voltage, which is same as voltage read by this branch. This is across these points. I would say phase voltage and line voltages are one and the same in delta. Currents are not same in delta. Currents are same in star, voltages are not same in star. So there is a small understanding. When we say line current, phase current, they are one and the same in star. Line voltage and phase voltage, when I say, they are same in delta. Remaining is not same. Currents are same, line and phase in star. Voltages are same, line and phase in delta. Okay, this you remember.